going to do lesson 38. This should be Wednesday's lesson. Hope you're all watching this lesson, and I appreciate all you that have put problems on the help board. That's been very helpful. So let's move on. Lesson 38, I think you're going to find that it's pretty easy. So we'll go quickly. I only have 4 examples. It's the power of sums, solving by factoring, and only 0 equals 0. The first one is power of sums. What we have here is we have a sum to a power. Now the tempting thing to do, which is totally wrong, is to cube this. I'm going to put a big line through this. This is totally illegal. To say x cubed plus 27. That is really wrong, and I hope no one ever does that, because that is bad. When you have a binomial to the third power, what you're doing is you're taking the x plus 3 times itself 3 times. Just like x cubed is the same as x times x times x, this sum cubed is x plus 3 times x plus 3 times x plus 3. Later on in the year, we're going to have a formula to do this so that you don't have to do all this multiplying. But for right now, we don't have a formula, so the only way you can do it is to take x plus 3 times x plus 3 times x plus 3. So you have to deal with 2 at a time. You can't, there's no way you can multiply all these together. So we're going to take these 2 first, and this is a binomial times a binomial, so you just use your FOIL method. First would be x squared. Outer is 3x, and inner is 3x. By now we should start doing the outer plus the inner in our heads. So 3x plus 3x is 6x. 3 times 3 is 9. So we got these 2 taken care of. We still need to take the product of these 2 times this one. So I'm going to do it the method where you just line it up underneath. We did this earlier in the year. The other way is you can take x times all of these and 3 times all of these, but I'm going to do it the vertical way. So we're going to take 3 times each one of these, in case you forgot how to do this. 3 times 9 is 27. 3 times 6 is 18x. 3 times x squared is 3x squared. And then I'm going to take the x times all 3 of these, and I'm going to line them up underneath their matching term. So x times 9 is 9x. X times 6x is 6x squared. And x times x squared is x cubed. We just draw a line, we add all the like terms together, and that's the end of the problem. So we get x cubed plus 9x squared plus 27x plus 27. And that's all there is to it. The main thing to remember is if you have a sum cubed, you have to take the sum times itself, the number of times of the exponent. Let's move on. The next part of this lesson is called solving by factoring, and we're going to look at the zero factor theorem. The zero factor theorem says if p and q are any real numbers, remember that stands for real numbers, and if p times q equals 0, so you have a product of p and q, then either p has to equal 0 or q has to equal 0 or they both equal 0. Like if p was equal to 4, we would have 4 times something equals 0. Then q has to be 0. One of these 2 have to equal 0. So let's apply this to solving equations. Let's look at example 2. First thing in example 2, you're going to notice that it's a quadratic equation. We know that because the exponent is 2. Whenever you have an exponent of 2, or 3, or 4, you need to set everything equal to 0 so that we can apply the zero factor theorem. So first of all, I notice that it's not like get x's on one side and numbers on the other side because it's a quadratic. So what that tells me if I see quadratic is set everything equal to 0. So I'm going to bring the 6 over to the left-hand side, and while I do it, I'm going to put it in order, in descending order. So we get x squared minus x minus 6 equals 0. You set everything equal to 0 when it's quadratic. Once you set it equal to 0, then we're going to factor it. I'm going to put 2 factors, and I'm going to get x, because x times x is x squared, and I'm going to get minus 3 and plus 2. Always check your outer and inner to make sure you get the middle term. So that would be 2x minus 3x is minus 1x. So what I just set up is two factors have to equal to two factors, and when they're multiplied together, they equal to 0. So what that means is this factor equals 0, or this factor equals 0. So I'm going to set them both equal to 0 and see what x would be. So this is one factor, x minus 3 has to equal 0, or x plus 2 has to equal 0. And that's how we're going to solve these. No matter how many factors they are, we're going to set all of them equal to 0, because one of them or both of them have to equal 0. And then I'm going to solve it. I'm going to get x equals 3 and x equals minus 2. So you get two answers to quadratic equations. You can check these to make sure it's right. You can put it up here into either one of these. If I put 3 in, I'm going to get 9 minus 3, which is 6, minus 6 equals 0. And it works. I can put the negative 2 in there. Negative 2 squared is 4, minus a negative 2 would be plus 2, so that would be 6, minus 6 equals 0. You can easily check these by putting them back into your original problem. Let's try one more of these. Another quadratic equation. You'll notice this time, though, there's an exponent of 3. So it's really not a quadratic. It's higher than a quadratic. So you're still going to set it equal to 0 and factor. So I'm going to bring everything, to make this positive, I'm going to bring everything over to that side. You want the first term to be positive. It makes it easier. So we're going to get x cubed. I'm going to bring this one over. Plus 2x squared minus 35x equals 0. So if it's a power of 2 or higher, we need to set it equal to 0. Once you set it equal to 0, you have to factor. So I'm going to look, I can see there's a common factor of an x. So I'm going to take an x out, and I'm going to get x squared plus 2x minus 35 equals 0. And then we can continue factoring this. We get x, and then we do our two parentheses. X times x equals x squared. We're going to get 7 and 5 equals 35. And if I have a plus 7 and a minus 5, we get minus 5x plus 7x equals plus 2x. So now we have three factors. At least one of these guys has to be 0 in multiplication for the whole thing to equal 0. So either x equals 0, or x plus 7 equals 0, or x minus 5 equals 0. This is already solved, so this is one of our answers. We're going to get x equals minus 7, and we're going to get x equals 5. Typically, whatever your exponent is, since see we have a 3 up here, whatever your highest exponent is, that's how many answers you get. You might get 2 minus 7s, but you should have, if the highest exponent is a 3, you should get 3 answers. Okay, we're going to look at the last problem here. This has to go with the only 0 equals 0 rule. If you look at this problem, we can factor out a 2. So always look for that common monomial factor. So I'm going to take my 2 out, and I'm going to get x squared plus 2x minus 35 equals 0. You're going to notice it looks very similar to this one that we just did over here. The difference is, instead of having a variable in front of the trinomial, this time we have a number. So we're going to factor x plus 7, x minus 5 equals 0. You'll notice we have 3 factors, but 2 cannot equal 0. So that's not an answer. So we're only going to get 2 answers. We're going to get x plus 7 equals 0 and x minus 5 equals 0. So our 2 answers are x equals minus 7 and x equals 5. Just remember, if it's a number out here, it's not going to give us an answer. And remember, we're going to have as many answers as we have at the highest exponent in our problem. So these are simple. Set them equal to 0, factor, set each factor equal to 0, and solve, and you'll have your answers. That's it.